Okay, so we'll begin with data visualization. So whatever we have done throughout in our course, like we mainly focused on pre-processing, right? Like if you have data, like why data is important? Why are we studying data analytics? Because data is being generated now a lot. Like in petabytes, you can see how YouTube data is flowing throughout. But most of them are unstructured data. Therefore, we have to pre-process those data, right? So we have to perform pre-processing like data cleaning, like if some things are redundant, right? Some columns are redundant or not. So how to do that, right? So how we can read the files, how we can read the data. So we learned about a bit of pandas. Okay, we learned some of the comments, like how many times a variable is appearing. So you can use value counts, right? If you have seen some duplicates, how you can drop them using drop NA or drop duplicate comments, right? So there are many comments which we have seen in pandas which can do things like very fast. And also like we saw how to extract first few rows of your data set using head, last few rows of your data set using tail. Okay, how to see the mix of head and tail, right? So we saw many of these applications. Then we saw how to handle noisy data, right? What is a noisy data? How you can use wavelets, right? How we can use pyramid algorithm to actually deal with noisy data, right? So how pyramid algorithm works, right? So we saw all those things using discrete wavelet transform, fine. Then what we did, yes, any missing part? Z score, yes. We also discussed about outliers in our data set, how to find outliers, right? How outliers depends like on the interquartile range and how on Z score. There are various different tests. Okay, how you can find that it is an outlier and how to deal with them. Like that, we saw how to what is skewness. Okay, what is left skewed, what is right skewed, right? And we also saw like in if your data is not normally distributed, if it is normally distributed, then of course mean is equal to median equal to mode. But when you have right skewed or left skewed data, then what happens to the mean, median, and mode, right? So which one will be a better statistical measure to choose? Okay. So, but in this class, we will extend the same. In this class, we'll try to extend the same. Before this class, you might be understanding that mean, median, mode, the central tendency measures are the one in all, right? Because they are the ones who tells us about the mean of your data set and also the median and also the mode, how many frequently occurring number is there in your data. So, but you will in this first few slides, we will see that if you know mean, median, mode, it is not sufficient. It is not sufficient. We will take 4 different data sets. It is a popular name, and we will show that even though the mean, median, mode are all the same in all of the 4 data sets, the distribution of the data is different. So therefore, even though the mean, median, mode is the same, you might be thinking that they represent a similar distribution of the data. But however, that's not the case. So this fact won't be clear until you visualize your data. So this brings me to the idea of data visualization. This is one of the most important aspects, that why you need data visualization, not only to generate cool pictures or plots, but also to understand how your data is distributed, where it stands stronger than the many various central tendency measures. It stands stronger than the mean, median, and mode. We will see only mean, median, and mode. If you compute for your data set, that is not enough. You have to visualize your data as well. So that's what we will discuss in this data visualization class today. And we will be looking at a lot of very nice looking plots. Okay, and we will tell, is data visualization enough? We'll answer this question. Is data visualization enough, or we have to do something more? So the answer is yes. Data visualization is not enough. We have to do something more than data visualization, right? And that is one of the most important aspects as well. So we will look into some animations, and if time permits, we will look into a TED talk. Okay, why data visualization is much important, right? Okay, so let's start. So as you can see, it is a data presentation step. It is as much as the data pre-processing step. It is the most. It is a step where you present your data. I mean, after your data is ready, cleaned, you present your data, right? So this is the data presentation step. So it is, you can see it is much easier to compare these plotted values than to compare numerical values. I mean, if you want to understand about that, I will tell you about this. So you can see, if you look into this bunch of numbers, does it convey you something? I mean, it will take you around 5 to 10 minutes to just scan through this data and understand what they mean, right? So therefore, you see a bunch of numbers here. That is not important. That is not important. If you can plot these numbers, you can quickly go through the distribution. Okay. So therefore, by visualizing data, we can get a better intuitive sense. You can get a better intuitive sense, right? Okay. So what is here? Hmm. Fine. So let's see. Hmm. Okay. Anyway, additionally, visualization can bring light the hidden patterns of your data. If you have a data set with you, then if you do data visualization on those pre-processed data, then you can find out the hidden patterns in your data set. That's one of the most important aspect here. Okay. So it can find out hidden patterns in your data. Fine. And moreover, I hope you must be knowing about this quote. A picture is worth 8,000 words. So I can tell you 1,000 words and I can give you 1,000 set of numbers. But if I show you just one plot, you can easily see that how the numbers are distributed, right? Fine. So, okay, let us come. So why we need to visualize data? So you can see it is essential example for creating visualization data. Like we'll take one example here. That this is the famous example. It is the Anscombe's quartet. Okay, why it is known as quartet? Okay, because you will have four data sets here. So therefore, quart comes into picture, right? So this data set was created by the statistician Frank Anscombe, who to show the importance of these statistical graphs. Okay, so what is this data set? We will look into this shortly. Okay, so what is this data set? So this data set consists around four sets of data. It has around four sets of data. Fine. So you will see four data sets in the Anscombe's quartet. Okay. And it contains two continuous variables. Okay. So what are continuous variables and what are discrete variables? Continuous variables are like discrete variables is like you can count them. But continuous variables are like you cannot count them. Like it will be like in form of decimals. 29.1, 29.111, 29.11101, like that. There are a lot of numbers like that, right? So therefore you have two continuous variables in that data set, right? But each of your data set, like you have four data sets, data set 1, data set 2, data set 3, data set 4. Now, what is special about those data sets? Those data sets, each of the data set has the same mean, same variance, same correlation, and same regression line. Understood? So these are four different data sets, and each of these data set has the same mean, same variance, same covariance, same regression line. So what do you think? This is my question to you. What do you think? Is the data, if your data set, each of your data set has the same mean, same variance, same regression line, then does it mean that the data sets are the same? All each of the four data sets are the same to each other. How many of you think they are same? I mean, each of your data set has the same mean, same variance, same regression line. Same means the data set 1 has the mean mu, and dataset 2 also has the same mean mu. Dataset 3 also has the same mean mu. Dataset 4 also has the same mean mu. each of your data set has the same mean, like all of your, I mean, yes, I mean, how are the values of the data set same, or the distribution, are the distribution the same? Are the distribution of your data set, each of your data set the same? What do you think? Yes. Okay. So we will be clearing that. Okay. And you will see. So when you visualize your data, okay, when you visualize your data, I will show you what this data set look like. Okay, when you visualize your data, it becomes obvious that the sets don't follow the same pattern. Okay, we'll see that. Okay, so this is one of the benefits of visualization and one of the pitfalls of looking only at the summary statistics. Okay, so what you might think, that if I have a data set, then I can take the mean, variance, covariance, median, mode, and summary statistics, interquartile range, whatever, and that is it. I have all the required amount of information about the data. Then it is not sufficient. That is the pitfall of summary statistics. So in addition, you have to do data visualization. You have to plot the data. You have to see how the data is distributed, right? So I will show you, these are the 4 different data sets actually of Anscombe's quartet. Okay, these are the 4 different data sets. Okay, so you can see here data set 1, it has x and y, these are continuous variables. Data set 2 also has 2 continuous variables. Data set 3, data set 4 as well, right? So what we do, we plot x versus y for each of these data sets. Okay, but what is the tricky thing about this data set is, you can see I have computed here the mean, variance, and correlation. Fine, and you can see they are the same. They are the same for each data set. I mean, you can see for data set 1, it is mean is 9 for x. The same is 9 for the second data set, for third data set, and the fourth data set. Okay, you can also check this correlation as well. I mean, you can compute this. You can compute this, but that is intuitive. That is intuitive. Why? Why it is intuitive? Because like, so I don't know. Uh, Okay, so it is intuitive. It is intuitive. You might be thinking why the mean of the 2 data set are the same, but it is intuitive. Why? Because you can always control by choosing the variables. How? If you say like 2 numbers 5 plus 4, what is their mean? It is 4.5, right? What I can do next? Can I fiddle with this 5 and 4? So even though the mean can be 4.5, what can I take? 6, 3. Yes, 6 and a 3. You increase 1 here, decrease 1 here, right? And you take the mean. It is still 4.5. It is still 4. So therefore you can, this is a basic idea. This is the basic idea, but you can do this with a chunk of numbers. You can do that with a chunk of numbers. Take some amount from one number, put that same chunk in another number. Okay. So that way you can make the means similar. Okay. That's one of the ideas. So this is the data set. Okay. Fine. So let us see. Let us see. So how this looks. Okay. So this is how it looks. Okay. So this is the first data set you have plotted, the second, the third, and the fourth. Okay. So obviously, the fact is like this is x, this is y. Yes. So you can see x is the same throughout, but it is the y that is varying, because y we always think is a function of x, right? So this is differently behaving for that set of input of x, each data set, right? So you can see the distribution is different. What I did, I just plotted each of these data sets here, 1, 2, 3, and 4. 1, 2, 3, and 4. Even though they have the same mean, same variance, same correlation. Okay. When you plot the data, it gives you the different distribution. So this is Anscombe's quartet, what we are looking at. So I thought of like showing this in maybe Python also. Okay. So this is the data set here. So we can find it. This data set is already there. Like in Seaborn, we will see what is Seaborn. Okay, but you can get this from the Seaborn library. Okay, so you just say SNS, like import Seaborn as SNS as usual, like import NumPy as NP. So you are doing import Seaborn as SNS. I hope that is clear there. Okay, so and we do SNS load dataset and Scombe. So when you do this, this is already pre-processed, like already there. So you just import the dataset and we print it. Okay, so you can see this is the first dataset. You can see how many numbers are there from 0 to 9. So each dataset has around 10 entries. Each dataset has around 10 entries, right? Then dataset 2, dataset 3, and dataset 4. Okay. So, to plot, I think, shall we wait to show this, or maybe I can show this? Anyway, we'll discuss this. So, to plot, we import this matplotlib plotting features. Okay. So, this is common. You will be using whenever you are plotting anything in Python. Okay, like same thing as you do import pandas is PD or import numpy is NP. So we'll be importing this matplotlib plotting features, and it is a bit different from the previous ones, like import numpy as NP or import pandas as PD. It is a bit different. How it is a bit different? So you can see matplotlib plotting tools are inside a sub package called pyplot. Okay, so we have to give credit to pyplot as well, right? Because matplotlib is inside the pyplot. Okay, so we usually import it and give it a short name like this as written import matplotlib.pyplot as plt. So whenever you want to plot anything, you can refer plt.plot. Okay, so that's the idea. Fine. So we will see here. Suppose I want to print the first data set, right? I want to print the first data set. So we have to create a data, right? We have to create a sub data set. I mean, we have Anscombe data set which has all four information of all four dataset. That is dataset 1, dataset 2, dataset 3, dataset 4. However, we want to plot suppose only the first chunk, first dataset. So we will create a subset, right? So we will select those values whose dataset number is 1, like this one, based on the second column. You can see the second column highlights which dataset it is, isn't it? So you can see the second column is showing you first, right? After 10 rows, it shows you second. That is the second data set. After 20, 0 to 21, 22nd row, it is showing you third, right? So we have to, our goal is to plot only the first data set. So we will create a chunk based on these first 9 rows only, first 10 rows only. So how are we creating this? So you can see, so we are creating a Boolean mask. Okay, I'm not sure if this will be covered in your Python course, but I think it will be okay. So it's just a Boolean mask. We will see what it is, but of course you don't have to worry about a lot, but understand the logic behind this. You just have to understand the logic behind this. So you can see we are creating a subset of which contains only dataset 1. We are creating a subset which contains only dataset 1. How? Dataset 1 is Anscombe, square bracket Anscombe dataset equals to I. That means you are telling that only select those values which has second column as I, right? So it is creating a subset. How it is working? How it is working? So it is written there. So this line over here is nothing but it is creating a Boolean mask. What does it mean? This will give you true or false. The inside thing will give you true or false, right? If it is I, it will give you true. If it is not I, it will give you false. So it is a dictionary of true and false. Okay, the inside the square brackets. Okay, so this is a Boolean mask. So it will return true when your dataset column equals to I, or else it will return false to you. Okay, now you will have, so you can see it is just a collection of true and false values. Inside the square bracket, you will have a collection of true and false values, isn't it? Here, sorry, yeah, in this, yeah, it's not. Okay. So you can see it is just a collection of true and false values that you can use to filter your data. Okay. So dataset 1 stores this filtered data frame. So now it contains only the subset corresponding to dataset 1. That means it will only find out those which are true, right? So false is automatically not there, right? Fine. So this is dataset 1. Similar thing you can do with dataset 2, dataset 3, dataset 4. How? You can just write here 2, 3, 4. So like that, you can create subsets, dataset 2, dataset 3, dataset 4, right? Okay. Now, after you created the dataset, the sub dataset, okay, subset of your original dataset, you have to plot it. You have to plot it. What does the dataset contains? So it contains exactly the same dataset, but the subset of it, only the first 10 rows. Okay, that because that is the first dataset, right? So you have to select only the numerical columns of X and numerical columns of Y, isn't it? Isn't it? So, okay, I will get there again. So you can see this was your data set. This was your data set. It has, you can see this column, dataset column, which tells that the value lies on which dataset. Is it 1, 2, 3, or 4? Right? So do we need to plot that? We don't need to plot that. Okay, we don't need to plot that. What we need to plot? We need to plot only the this column, X column and Y column, right? We have to plot only the X column and the Y column of that corresponding subset, So how you can get that? You can get that with this command, right? Dataset 1 bracket X. Okay, you are telling that take that column. Okay, and comma dataset 1 Y column. Okay, so plot X comma Y. You pass through the X data and the Y data. Yes, how we are doing it? PLT dot plot. What is PLT? What is PLT? Yes, you have created an alias. You have created an alias, right? Import matplotlib.py pyplot as PLT, right? Fine. This is okay, right? So we are using plt.plot and we are giving x comma y as the arguments there, right? So it is plotting. Now by default, okay, we'll come to that. Dataset 1x is the x values from the enscombe dataset 1 and same the y values, okay? So, okay, you can also add a title to your plot. It is a good thing to add title to your plot. Okay. So how to add title? Plt.title and double quotes. Whatever you write will be there as a title of your plot. Okay. You have to give X label and Y label, right? Because the plot I had shown that for data sets, the distribution, that was not a good plot. Why? It had no title, it had no X and Y labels, it had no mention of dataset 1 or 2, 3, 4, right? So it is not a good plot. Okay, so the idea is to make nice plots or informative plots. Okay, fine. So this is the Y label as well. Fine. So you can see it is plotting over here. So you can see X is plotted like you can see properly. But when you see the Y label, it is rotated. That is the default way. That is the default way, right? Y, if you need Y like in a horizontal manner, that means you have to rotate it. So you have to give an additional argument. Okay, you have to give an additional argument. Some people like it, some people don't. Okay, some people don't like to see 8 numbers 4, 6, 8, 10, 12, and numbers on the y-axis also 4, 5, 6, 7, 8, 9, 10 are all in a proper way, that you just how you write it. But y is the only one which has been by default rotated, right? Because it is on y-axis. However, many people don't like about this. That's the odd man out there. So what you can do, you can write a separate argument to rotate it, to rotate that y label, okay, and it will appear just like y, how you write it in your notebook. Okay, so this is just one thought. And by default, when you do the plotting plt.plot, it will be just a line plot. It will be just a line plot. What do I mean? I mean, the data set only has a discrete set of points. Agree? 10 set of points. Now what does this plt.plot does? By default it will connect those lines, it will connect those points, right? So does this give you any idea of your data set? No, it doesn't give you any idea. Why? Because the points are already being plotted like joined by straight lines. You don't know whether the point is here or the point is here or here. Of course, you can see the vertices will be the points. The vertices, I mean, these are the points. After a bit of experience, you can know that. But when you are a beginner and starting out, you don't know whether the point lies here, 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 right? So therefore, by default, it will join the points. However, if you don't want that, you can do something more. Okay, but by default, it will join the points. Okay, by default, it will join the points. Fine. Okay, we'll see that. Okay, but one more important thing is after you do plt.plot, it is not enough to show you this plot. You have to type plt.show. You have to type plt.show. Okay, that is mandatory. That is mandatory. So we will need this to show explicitly to show our plot. Okay. So what it does, it tells plt.show tells matplotlib. Okay. Now display everything I have set up so far in my plot. So therefore, even though you write plt.plot and dataset x comma dataset y, it is not enough. After all that things, you have to tell that yes, show the plot. So you have to do plt.show. Plt.show, that is mandatory. Okay. If you don't do that, the plot won't come. The plot won't come. Anyway, so as I told you, by default, plt.plot will draw lines. So if you want to draw points instead, I mean, we want to only plot our first dataset points and we don't want to join them by lines. Okay, this is our idea. Okay, this is our idea. So we can pass in a parameter, okay, say like this O, right? And tell that plot each of this dataset entry with a point. Okay. However, you can change this. I suggest that okay, I had planned that before coming to the class, I should have shared this notebook with you so that you can check with your laptop also now. But anyway, I forgot that. Anyway, so you could have practiced after this. Maybe what you can do, play around with symbol. You can put a star mark. You can put a triangle. Okay, you can put a what do you call that? I forgot that letter. What do you call this? I forgot. What is this? Cap. Yes, good. Without drawing also you noticed. Okay. So therefore it tells you all is in your brain. It is not only in your eyes. Okay. The pen had no nib. Okay. Anyway. So what we can do, he is saying that plt.plot dataset 1x, the same dataset 1 is the subset, right? And dataset 1y, and we are using this as a marker. This is known as a marker. Okay. Marker. Okay. By default, it is blue color. By default, it is blue color. It is not mandatory. You can change your colors also, but you have to give extra parameters for that. I mean, comma, color, and you can use whichever color you want to use. Cyan, magenta, orange, brown, blue, whatever it is. It's suppose a wide range of palettes of colors. plt.show. Now you can see it was the same data set, but here the lines were joined. Sorry, points were joined, but here the points are there. It is not joined. Okay, it is not joined. Fine. Okay. However, it is not a good plot. Why? Because I have not provided any x and y labels. Okay, you don't know what is this x label, what is this y label. So again, you have to write all these things like plt.x label, plt.y label, right? Okay. So fine, let us be back. Let us be back with our uh, uh, let us be back. We will go back again to Python. So yes, before that, you can see these are the popular plotting libraries of Python. You can see matplotlib. So very nice to create these 2D graphs and 2D plots. Pandas visualization. In Pandas also you can do data visualization. Okay. Seaborn that we will discuss in this class. Like Seaborn provides a high level interface to draw very attractive and high quality diagrams or figures. Okay. So you will see that how much we are writing here, many lines of codes we are writing to do X labels or X's or many things, these won't be there in Seaborn. In Seaborn, you can just write one liner code which can draw you many things. Okay, and it is very interesting also. Fine. ggplot. So if many of you know about R, so it is based on R's ggplot2. Okay. Okay. Plotly, you can, I think we will use it in the middle of our collab notebook. Okay, Plotly. It can also create interactive plots. Okay, I think some interactive plots in today's class is made with Plotly also. So these things you should be knowing. I mean, it should be there in your mind. It should not be unknown to you. Okay. So anyway, so this I already told in our collab notebook that matplotlib is the Python's fundamental plotting library, extremely flexible, gives user the full control over all elements of the plot. Okay, all elements of the plot. Fine. So what do I mean by that? What do I mean by that? Hmm. Hmm. Fine. Okay. I asked what is this? Why you are giving a different answer? Okay. I'm saying that matplotlib is extremely flexible and gives the user full control over all elements of the plot. What do I mean by that? Yeah, I was asking why. Anyway, so okay, we'll be back. So this Enscomb's data visualization tool, you can illustrate why just looking at the summary statistics like or central tendency measures is not enough. Okay, you have to look into the data visualization or the data distributions of those data sets as well. Okay, so I hope that is clear. So now what we saw, the moments the points were visualized, it became clearer that even though each data set, each of the four data set had the same, like the summary statistical values, that is mean, variance, correlation, the relationships between the points differ across these data sets, that is data set 1, 2, 3, 4. Okay, we saw how they are distributed also. Okay. So this is, okay. Okay. So this was the left side represents the matplotlib anatomy of a figure, the old version. Okay, what does it has? It tells that this is the whole figure. Whatever you see, I mean axis, y label, x label, the title. This is the figure. This is the figure. Okay, this is the whole figure. This was matplotlib's anatomy of a figure, the old version. Now, when you look into the new version of it on the right hand side, it tells you the new anatomy of the figure. What is the new anatomy of the figure? You can see, like, if you do plt.figure, it is creating this whole figure, but now it is making more focus on the tiny bits inside your figure. What are the tiny bits? It tells you even though about these tiny ticks. So these are the ticks in your plot. These are the ticks. Okay, these are the ticks in your plots. So these you see, these are minor ticks. Okay, and these are the some of the major ticks. So if you are using a log plot, log plot, or any plot, you will have to deal with this major and minor ticks. If you do not draw a normal numerical value plot, you don't have to worry about the major or minor ticks. Okay, you will have only one kind of ticks. Okay, fine. They see also about the labels. Okay, they also see about the x-axis label. Again, the ticks here also. Okay, and how this, if you do a line plot, this is known as a line plot. So how you are plotting this line plot, and you can see these two plots are in different colors. One line plot is in blue, whereas another line plot is in orange, right? So you can deal with that color of your line plot also. Okay, fine. And also about the markers. I mean, you can do a scatter plot also. We will come to that. Scatter plot means you don't join them with lines, the points. However, you just plot the points individually, and it is just appearing like it is these points are scattered. So therefore, the name scatter plot. Okay. So you can see, you can choose whether the marker will be star, the marker will be circle, the marker can be The triangles, the marker can be upward triangle, downward triangles. Okay, even though you can choose the marker to be just tiny dot. All these things you can take care in Matplotlib. Also, you can add grids. Also, you can add grids here. Over the background, you might see these are the grids. And these grids can give you a lot of information, it depends whether you want to use it in your application or not. Depends on the subject you're working on. I mean, right? I mean, sometimes it might be clustered in this grid. So you can clearly see that the value lies between 1 and 2, right? The value lies in between 1 and 2. So therefore, the clusters lie straightforwardly. You can see it is lying in between 1 and 2. Agree, right? So therefore, grids are also important. Okay. So you can, but in some cases, grids are not good. In some cases, grids are not important. They just distract the figure. Okay, that they just distract the figure. Fine. Good. So now we will come to two things. Now you must be knowing about axis, and something you saw is about axis also. Now, what is the difference between the two? Okay. Now, what is the difference between an axis and an axis? Okay. Okay, this is one of the most confusing conventions in Matplotlib. Okay, one of the most confusing notations, but is important as well. So we'll see this. So you can see the outer container that holds everything, all the plots or subplots is something referred to as axis. Okay, so it's the plural of axis, and it's actually means kind of a subplot. Okay, I mean, if you have 4 different subplots here in a figure, okay, remind yourself about the Anscombe's quartet. Remind yourself about the Anscombe's quartet, how the 4 different dataset plots were the subplots, and that was a total figure. That was a total figure, and each of the figure was the distribution of a dataset. Dataset 1, dataset 2, dataset 3, dataset 4. That is what I meant by subplot. Each of them, the whole thing is a figure or a plot, but each of the plots inside that is a subplot. Subplot 1, subplot 2, subplot 3, subplot 4. So what does axis and axis mean? So you can see it's the plural of axis, but it actually means a subplot. Okay. So axis with capital A refers to a single plotting area. That is one subplot. Okay. So it is a subplot. So what does each axis contain? Each axis contain an x-axis and y-axis, of course, the data, which ticks are you applying, what are the labels of your data, all those things. Okay. So remember your Anscombe's data quartet data set, the 4 subplots. Okay. Axis 1 that corresponds to the top left subplot. I mean, if you have these 4 subplots over here, axis 1 means the shaded one right now. Okay, the topmost left subplot. What does axis mean? Axis mean the horizontal and the vertical y-axis. Okay. So axis AXIS lies inside AXES. Okay. So you can think of like AXIS lies inside AXES. Okay. So therefore, AXES axis with an E means a subplot. Okay. And inside that subplot, you will have a x-axis label, sorry, x-axis and y-axis. Those are known as axis. I hope you got the idea, right? So AXIS lies inside AXES. So each axis object has 2 axis objects. So this line tells the whole story. Each axis object has 2 axis objects. Okay. So you can see what are those axis objects? The horizontal x-axis and the vertical y-axis. Okay. Fine. So I hope that is clear here also. You can see this is the axis. The x-axis or y-axis line inside a subplot, whereas AXES is one whole subplot with both axis lines as well as the data. With both axis lines as well as the data. Okay. And what is the figure? Figure is the whole collection of subplots. Figure is the whole collection of the subplots. Right? Fine. So in our visualization, so for univariate, multivariate, bivariate, sorry, univariate, bivariate, and multivariate, we'll be using a predefined data set, that is tips. Okay, you can get that tips data set. What does the tips data set gives? It is a data set which is about a restaurant. Okay, what is about the restaurant? Like how many persons are going, to the restaurant, how many males, how many females, at what time they are going, how many of them are going in a lunch hour, how many of them are going for dinner. Okay, and when they are going and having a meal, okay, so they have to pay a price, right, for the meal. So if they pay a price for the meal, if the price is it higher or lower, the meal price, if the meal price is higher, then what tip they get, what tip they give to the restaurant. Okay, and if they ate only a burger or something, the price is very less, so what tip they give if they eat a burger, right? If they eat like one full biryani set, then what price they give? Okay, so that's the idea, so we want to understand, so as a restaurant owner, I want to understand the analytics behind this, so that I can attract a lot of customers, right? I can know whether I have to change my timings, which timings I have to focus more. I mean, if you see that, yes, those who are coming with only just spending tiny amount of money for small meal, they are giving very less tip, right? You will see that. Okay, you will give less tip, right? But so what can we do? We can pair a burger with some cola and some chips. You are already getting it, but I mean, if it was not the case, right, then the meal price was much pricer, right? The price is more, and you will give a bit more better tip. You'll give a bit more better tip, right? That's the idea. So this is how your market can understand through the data. Okay, we'll see this. We'll see. So the tips data we'll be using for the next series of visualization come from the Seaborn library. So from the Seaborn library, it's already predefined there. This dataset contains the amount of tips that people leave for various variables. Various variables like how much they spend, when they eat, okay, how many persons they brought with, okay. I mean, if you are going alone, you are likely to give less tip, and when you are going with a bunch of your own colleagues, you will give a more tip. Okay, that's the psychology around. Okay, so that's the idea. So you can see the total cost of the bill. What are the variables? The total cost of the bill, the size of the party. Okay, if you are alone, you might not give any tip. Okay, however, if you are with some other people, you will give some tip. Okay, the size of the party, the day of the week. Is it a Monday or is it a Monday? If it is a Monday, then you will be in a working mood, so it won't be there. If you are on a Saturday or Friday night, then you will be in full mood. Okay. So time of the day, whether it is lunch or dinner. Okay. People with more health conscious, they prefer lunch. They won't prefer to eat a lot heavy things at night. Okay. So depends. Okay. Good. So this is what we will be discussing, univariate. So we'll discuss a series of data visualizations for univariate. I mean, what is univariate? In statistics jargon, like the term univariate refers to a single variable. So the term univariate refers to a single variable. Okay. Single variable. If it is bivariate, you will mean two variables. If it is multivariate, you will have multiple variables. Okay. Fine. So this we will see. The first one is histogram. Okay. I mean, if you want to analyze only one variable, so the best one is to look at is histogram, right? How? So histogram is the one of the most common means to look at single variable. Of course, you have to know when to use which data visualization, when to use which plot. Okay. So if you want to look only at a single variable, how the single variable is distributed, right? So for example, I want to know in the tips data set, I want to understand what I want to understand. Yes, I want to understand what the tips. I mean, I want to understand what is the distribution of the tip money the restaurant is getting, right? So what I can do, I can only analyze the tip variable. That is only one variable. So if I do this, then you can see the frequency over here. Hmm? Anything? No. So you can see the total bill on the y-axis over here, and this is the frequency. Okay. So you can clearly see that the bill of around 65 rupees or $65. I think it is a foreign data set, so I think it will be in dollars. So the maximum tip may be around $65 or something. I mean, if they go with a huge group, I don't know if it is 65 rupees. We have to check. We have to check the currency of the data set. Okay, you have to check the currency of the data set. Okay, so that's the idea. So you can see this is the plot over here. I'm not sure. You can Google the tips data set. 6,000 rupees. 6,000 rupees. Who told six? Yeah. I mean, we see in abroad it is okay. It is common. Might be. If you go in a big family, yeah. I mean, for some, okay, yeah, that is, yeah. So you can check. So I suggest now you guys can check the tips data set. Check the currency in the tips dataset. However, I don't know. I suggest everyone to Google it. Tips dataset in Seaborn library. Google and check whether the currency is dollars or rupees. Okay, he might be the rich guy. We don't. Anyway, that's for you to explore. Okay, so you can see how the distribution it is. Also, anyway, this is the idea. Dollars is it? I mean, we don't know whether the data set is actually a, I mean, it should be a true data set only because it is a predefined data set. Yeah, yes. So this you can play around with this data set. I mean, you can take the histogram, you can play around with other variables and check. Okay. So that's the idea. Okay. Let us go. We'll see how to do this. Okay. Anyway, so again, this is the idea here. So this is a graphical representation of your data using bars of different heights. But keep in mind that in your histogram, the bars are close to each other. I mean, they don't have gaps. They don't have gaps. Okay, they don't have the gaps. However, in bar plots, you can have the gaps. Okay. This is one of the difference between this histogram and this bar. Okay. Anyway, so this is the idea. So when you want to see why you want to use the histogram, first of all, so you can see if you want to analyze the frequency distribution, like we analyzed the frequency distribution of the tips. Okay. Or later, if you want to understand what is the frequency of males going in and how many females are going into the restaurant, right? So if you want to analyze that also, you can use this histogram technique over here. So what you can do, you can just give this command just for your idea, plt.hist, plt.hist, and just pass the data which you want to plot. I mean, here it is showing the car's data. Don't need to worry. What is car's data? Might be what's the mileage? Okay, how many kilometers it has driven throughout its purchase till now. If you want to see the distribution over the time, then you can see, and it will be lot of columns, lot of entries, and lot of features will be there in your data set, car's data. But you want to focus only the kilometers, like the distance it traveled. So therefore, the square bracket and kilometer. So there will be a column named here like this, and there will be a lot of variables here that you want to see how the frequency distribution is. So when you purchase the car, the distribution may be higher because you are very excited to drive it. And after that, it will be slowly, gradually reducing because you will be get bored of the car. And maybe in between it will increase somehow during festivals, something like that. So you can analyze the frequency distribution of the distance traveled in the car. Okay, fine. So this is, I mean, you can see over here. Okay. So, of course, this is the difference between the histogram and the bar chart over here. So you can see if you have this continuous data, I mean, distance is a continuous data, like 53.6 kilometers, 53.602, 53.613. So this can be very, very continuous. Okay. So what are discrete? One, say, or two, or maybe -1, -3, which you can count. Okay, fine. So this is for continuous data set. Usually you can try histogram. Whereas if you have discrete or categorical data with you, you can try bar chart. However, you can see one of the most important difference between them is the spacing. Okay, whereas in your histogram, you cannot have any gaps. Okay, because your intervals are continuous. Your intervals are continuous. How? Suppose you say, what do you mean by interval? Suppose the car data, if you say the distance between 0 to 100 kilometer, so you are binning them. You are binning them, each of your width of the histogram. Each of the width of the histogram is a bin. Like say 0 to 20, say 22, 21 to maybe 20 to 30, or say 40, 20, 40 to 60, like that, same 80 to 100. So therefore these are continuous, so there cannot be any gaps, there cannot be any gaps, right? So therefore you can see there are no gaps, whereas in bar chart you can have spaces. To divide, why we have spaces? Maybe you can create a bar chart, one bar chart for male, another bar chart for female. Okay, or maybe you can create 4 different or 5 different bar charts according to the behavior of the people. Okay, one is introvert, one is extrovert, one is semi introvert, semi extrovert, something like that, and many classes. Okay, you can create this. Fine. So this is the idea over here. So it represents continuous intervals of continuous data. So intervals, so this is important, intervals of continuous data. Okay, but here in the bar chart on the right, you can see each bar is a distinct category, and there are spaces between the bars which highlights different categories, which highlights different categories. Okay, fine. So fine, this is the ideas over here. Okay. So maybe we can look into that in Python before we go back here, suppose. Maybe. Let us see. Okay, yeah, okay, so okay, computer got stuck. Okay, we can see what Plotly gives to you. Okay, we saw Plotly can give you highly interactive plots. So this is just, a illustration how Plotly can be useful. Okay, how Plotly can be useful. So just to show you that, after that we will go to histograms and all. So here I have selected this data set from this GitHub repository, which gives us the GDP of some selected countries, not all countries, mind you, GDP of some selected countries, and it was given in that GitHub link. So there are many countries which are missing. Okay, so you can see I have imported. Okay, so I'm trying to create a line plot over here. I'm trying to create a line plot, and what is my idea? My idea is to plot a GDP of a particular country over the years and how it is varying. Okay, GDP of a particular country and how it is varying. That is my idea, right? So you can see I am importing plotly.express as px. Okay, that is another alias. Okay, you can use plotly. You have seen how I imported Seaborn, right? How I imported Seaborn, import Seaborn as SNS, right? And even you understood how we imported matplotlib. Okay, we have to take, since it is under a sub package, we have to call that also. So as PLT, right? So now here you are using plotly. Okay, express as px. That's another alias if you want to use plotly's features. So again, it's one of the most one of the main plotting library in Python. Okay, and very useful to create highly interactive plots. What do I mean by interactive plots? That will be clear when I show the output. Okay, how why it is interactive. Okay, so Express, if you want to know more about it, I have written it down. Express is again a submodule with some simple and high level plotting functions, and PX is another short alias like that. Okay, so yeah, good. So if you're not able to see last, you remind. Okay. So Express is another submodule with this I already told, high level plotting functions, and PX is another alias like you do with Seaborn as SNS. So PX is another alias. Okay, short alias. So now what you can do if you want to create a scatter plot, you can directly use px.scatter, or if you want to use create a line plot, you can simply use px.line and pass the arguments within it. Okay, fine. We are calling the Seaborn library, we are calling matplotlib also. And this is the URL where I'm getting this data set as a CSV file. Okay. So creating a data frame df pd.read CSV from that URL and px.line. Okay. So here I'm creating a line plot. How I'm creating a line plot? The line plot will plot this data frame, and what it will plot? It will plot the x part will be the x-axis will be having the year, the y-axis will be having the value, that means the GDP. Okay, and we are coloring it, we are coloring each of the line plot according to the country name. I mean every different country will have a different color for that line plot. Understood? Every different country will have a different color to that line plot. That is the idea. I hope that is clear. Okay. And you can give the title also, GDP countries over time. That's the chart title. And this is one of the very nice interactive feature in Plotly. That means you can give the hover name. Hover name equal to country name. What do you mean by hover name? I mean when you hover over the plot, it will give you, it will pop on the screen which country it is. I mean if you hover over the one of the line plot of a particular color, it will give you interactively which country it is. Okay, so we can see that, and you can show here instead of plt.show, you are doing here figure.show. Okay, let us see how this. Okay, gone. Okay, sorry for that. So what happened here? If anyone can tell, it will be really good. What happened here is I just put my hands over it and it got zoomed. Okay, so that's the feature you have in Plotly. Okay, you can zoom into the figure also. So therefore you see the empty chart because that's the part I zoomed where no plot was there, no line plots were there. Now you can see over here how I can plot, and these features you can see, right? Which part I want to uh, extract or something like that. But anyway, let us see what I mean. I'm not able to control over here. Let me run one more time. Just to show you the power of hover, you can see here. You can see here like which country it is considering. Like this is every country has a y-axis as the value, the what do you call the GDP, and the x-axis are the years. So over the years, how different countries GDP has increased. Fine. So many countries are there like Albania, Algeria, Afghanistan, African, Eastern, Australia, Austria, Brahmas, Armenia, many countries. So first one, Afghanistan, the pink. Yeah, it is saying the world. Yes, I think the data set is a bit gone corrupt. Maybe that's yeah, that's a good question. So this is what I want to tell you. This will be coming towards the end of this lecture also. Just by seeing the plot, uh, it is a good plot doesn't mean all the things. You have to question what is the first one. What is which country has the largest GDP? What is the pink color, right? Unfortunately, it is showing world. I don't know why. Okay, second line is also gone. However, take care. Like after some instance, it is giving correct country name, but after some time, it is not giving you the correct country name. I think the data set is bit having a bit of an issue. Why? Because if you see the below countries, I mean Take any one country, you can see China over here. Okay. However, yeah, that is a bit non-trivial, right? That is a bit non-trivial. So don't worry about this. I very poorly got this data set. Okay. Getting data set is also a bit difficult. So anyway, to show this on Colab also, I have to get a data set from a GitHub repository. So it is the CSV file from that. So think, maybe you can think the pink is India. Okay. Think pink is India. Okay. Maybe. So, but what I wanted to show you is that you can hover over. So when you hover, what it gives you, that's the idea I want to show you here. Okay. So you can see whenever you hover around a particular line plot, it gives you different country names. Maybe here only. I don't know. Is it an error in the code or something? I don't know. But these countries it is giving properly. Like you can see France, Japan, Germany, East Asia, those things. But the moment I go above, this one is Europe and Central Asia. But yes, sorry again, can you tell? Groups of data. I have not checked the data set. Okay, can you tell again? Okay. So Europes are together like combined. Yeah. Oh, but then I see this separate also. Oh, separate is also there. Separate is also there, and Asia will be there, Europe will be there, all these parts will be there. Mhm. Fourth, yes, fourth, yes. We are the fourth ones. Who is the first? Yes. So that's our goal till 2047, right? That's our goal till 2047. I. Okay. Huh? Yeah. So this is how the debate should be, right? So when you get a data set, when you plot it, then you try to get information from the data set, which has the highest GDP. Okay, therefore we see that yes, we are a bit fourth, so we have to go ahead, right? We have to march ahead, right? So these are the information we get. Anyway, so this was one of my aim to show to the class that PyPlot can give you these interactive plots, right? I mean, you can have hover feature also where you hover over each of them, and with that only it will give you what is the value and country name, which year it is, all those things. Okay, so it is quite interactive. So therefore, you saw how Plotly can be good. Okay, fine. So okay. So now before that, remind yourself. Okay. So shall we take a break or?